Today we're going to talk about bottlenecks in serverless applications. Basically, this is going to be sort of a lecture discussion. If you guys feel like you want to ask something in the middle, you can just raise your hand and I will try to ignore you. But if not, I will take your questions. So what are we going to talk today? Let me just get my clicker. So we're going to talk about what is serverless, how it can help us. A little bit about, not a little bit, the entire presentation about bottlenecks in how it used to be before the serverless era and after, and how they act completely the same in terms of how their damage to your business, how we can overcome them, and then I'm going to share some real serverless experience and tips and see how we can, maybe you guys can throw some suggestions on how to really solve them. So I'm Chen. I'm from Tel Aviv. I work at Hexagon. Hexagon, for those of you who not know, we do a modern monitoring for modern applications. In my past, I was in the intelligence forces, where I did mainly in Israel, where I did mainly R&D and embedded, and then I started chasing different technologies from industrial robots, and then I have a new chase, which is my daughter. Her name is Yuval. She's sort of, well, for those of you who have children, you know that children are the bottlenecks of all your things that you plan to do. So sort of stuff that you can stop doing. But now she's 1 year old, and I can say that she's sort of my engine to how I start doing things. So it gets better. So let's kick it from the start. So what is serverless? So most of you, all of you, I hope by now, the second day, you already know. But usually when people talk about serverless, the first thing that comes to mind is Lambda, which is like a similar word to serverless. But not only, if I'm going to try to explain it to someone who has no idea what is serverless, so think about the way you used to develop your code. Now you don't need to worry about anything that is not related to what your business does. For example, if you have a service that is sending, I don't have any coming to mind. For example, if you have some image processing company, so your people, your team, all they need to do is to develop stuff that are related for the image processing, and that code doesn't need to. No one needs to worry about the service that it's going to run. So you can just take a piece of code, tell the vendor to trigger it on some sort of conditions, and from there, all types of vendors gonna make sure that this happens. So serverless is not just about functioning as a code. It's also about all the different resources that we use. For example, if you're gonna use third-party APIs, this means that the part of our code that runs, it also runs on a serverless environment for us, because we don't need to worry about the infrastructure and don't need to focus on anything else but the business logic. So why serverless? First thing is pay-per-use. For those of you who've been yesterday, you saw that sometimes pay-per-use, it can reduce the cost to 90%, but sometimes it can be, it can even increase the cost, depends on if you monitor it or not. But usually, pay-per-use is the way for us to be able to scale from nothing to a million, because when you open a company, you don't know how many customers you're going to have. You know what is your aspiration and what you want to happen, but you don't really have an idea of how much traffic you want to get. And getting this ability to pay only for what we really take and what we really use, it's something that servers brought in, and I think it's done to many young startups magic, because they can scale easily and they don't need to worry about bringing on a DevOps team that's gonna build entire infrastructure, and then don't need to order servers, and they don't have all these limits that you used to have. All they need to do is just write the code, and they have AWS or Google or any other vendor that can really do that for them. So if I'm going to talk about function as a service or Lambda, there are some limitations. The first limitation is that we give the vendor the ability to run our code, but this doesn't mean that we can do anything that we want. So the vendors usually limit us by multiple things. The first thing is memory. When you first, how many by raise of hand use Lambda here? Friction of a Lambda? AWS Lambda.
You're asking about AWS or about the concept of Lambda?
About AWS Lambda.
Sorry.
Okay, so how many are? Yeah, so you know that you need to select like how much memory you want. You also need to, you have a limited running time that you have. And also there's the cold start that is like a voodoo for everyone that is trying to deal with that. You don't know what is it's sort of a limitation, but because cold start, for those of you who don't know, each time your code runs, it invokes a container. And if it's going to run frequently, that container is going to stay hot. But the first time the container runs, it's going to perform a cold start. So it's going to take more time than usual just to initialize the container and yet let your code run on the AWS runtime. And the fourth thing is that it's stateless. So stateless means that we no longer have, like we used to, we don't have a place in our program that keeps on a state. So if you want to put on propagate a state, we need to either use step functions or to put it on DynamoDB or to put that state on S3 or put it some other external storage that we don't have access to. It's not exactly a state, but there is a way for your Lambda functions to share memory for a certain amount of time. This is what I meant when I said about the cold start. So your container is running and you can keep stuff, but it's not something that you can really rely on in your application. This is usually something that is useful for doing caching. So you can just have some of your, if you're going to talk with a third-party API, you can save all the data coming from in the container, and then the next Lambda's invocation is going to use that cache, but it's not resembles anything of state. So there's also concurrency limits, and also for each service, there's other limits that we'll discuss it later on in this lecture. A little bit about the properties of serverless. So if we took the monolith, broke it into microservices, serverless is called microservices, but it's really smaller pieces than that. It's like nanoservices. And what it means that now that we only took our microservices and we broke them into teeny, beany, bitey pieces, because we can, and because we can make that application become much more highly distributed, it's going to be event-driven by the way that our code is running by events and not by someone that logs in. And this gives us the way to use many third-party APIs. For example, if I want to have in my team that image processing, I don't know why I use that example. If I have that image processing service and I want customers to start paying, or I want customers to authenticate, or I want to save that data on some storage, I'm not going to do anything. I shouldn't do anything on my own, because now I'm going to take my team and put them all focused on other stuff that is not part of their business logic. So I can use stuff like Stripe or stuff like Auth0 to authenticate. And many companies adopted that. I think the best example that I came across is to make that sort of a shift in the state of mind for moving from monolith to serverless is something that been presented in the reInvent last year. If anyone here been there, it's been of HSBC, one of the largest bank companies. They started to develop what is called a way for their customers to get SMS each time they're going to do a transaction. It's like a digitalized the way that it used to work so far. So they have these mainframes and old pieces of things that right now are using direct connect of AWS to stream data to their entire serverless application. So you can see they have Kinesis streams, they use API Gateway, DynamoDB, they use Aurora, which is the RDS, serverless RDS version. With Aurora, you can just, you don't need to mind about scale in terms of RDS. So it can scale up and scale down all the read operations and write operations, also the storage. It's pretty good. It's more pricey than just doing it manually, obviously, but it can work good if you need some RDS and still want to scale similar to DynamoDB. They also use SNS and SQH, which are message queues that are managed, and they build a pretty good application. So some of their discussions is about the problems that they have with that, and this leads me to talk about bottlenecks. So if I can go back to what I said about my daughter, there being a bottleneck. So I have some story about it that I just came one day to the house. My wife made this cake, and my daughter started now to walk, and she got into the cake and kept eating the cake. And this means that if there is a cake and you come back from work, and usually 2 people eat that cake, and there's now a cake monster that is eating a lot of cake, this means that cake monster, which is beautiful, but she's a cake monster, is taking all the cake. And she's the bottleneck in that terms of cake. So what I did is an experiment to see how I can solve this, just so I can show this in this conference. So we tried to educate her and tell her that she's not supposed to touch the cake, but then she told us she doesn't care. And then we just tried to, this is the cake, by the way. She kept reaching it, so that told my wife, okay, no more cake. This is in Hebrew. Cake is uga, and no more is, N is no more. I told her N uga, Yuval, and Yuval is the name of my daughter. And this is how we solve the bottlenecks problem. So So she didn't really take it that well. So she just took her bag and ran to her boyfriend on a motorcycle, and we never seen her since. She's fine. I know she just got a new tattoo here on the thigh. We all wish her good luck with that. But we got our cake, so I think it's a win to us. And so if you're trying to think about how to solve bottlenecks, first we need to remember how it's like to have bottlenecks in a non-serverless environment. So before we were in serverless, let's think about that we just built, for this example, we built a website that all it does, you have an application load balancer. We have EC2s running, I don't know, like Flask or some framework in Python that is currently accepting all the clients that are coming and trying to authenticate, and trying to write all the data to some database. So anybody here can think about possible bottlenecks that can be in this diagram? By a raise of hand? Yes?
In that way, I think it could be like because it's 2 services running at the same time.
Yeah. Most databases can handle concurrency, but this definitely can be an issue somewhere here. So some of the limitations can be either on if you have some logical issues, and that database can be sort of a problem. So that database also runs in some server, and all of them can have issues like you can have CPU, you can have RAM issues, you can have storage issues, and you can have anything that is wrong in the logic that you just wrote that can cause bottlenecks. And in serverless, it becomes a bit different, because if we're going to take all those 2 EC2s and database and turn it into a serverless environment by switching to API Gateway, Kinesis, Lambda, and DynamoDB, things can get much more complicated. So who wants to think about what can happen here and what can cause bottlenecks in this type of system? You were smart before with the RDS. Yes.
One would be exceeding concurrency on Lambda. Another would be DynamoDB if we don't have automatic scaling or automatic provision. Kinesis can run out of streams because it doesn't automatically scale, and API gateway can be throttled if our limit is set too low.
Yeah, so now that we are using these managed services, this doesn't mean that they can scale infinitely, and this doesn't mean that, well, maybe each piece here can scale. Maybe the Lambda can run for many invocations that it can, but now because it's been communicating with other services in our system, we need to make sure that all the input and output throughput of each service really matches. So in this example, what will happen is that if there is any issue here, the first thing you're going to see, because you have a Kinesis, you're going to go to the cloud.metrics and you're going to see the iterator age just jump to the skies. And this means that all the data that was transferred from the API gateway to Kinesis is now waiting, and all the requests got from your users are now in line, and this can be a very long line. And if you have something that is very crucial for your customers, they can also experience that in terms of their experience in the product. For example, if they post some blog post and that got to the Kinesis, you can wait a few hours. You can wait infinite time, actually, until you're going to fix the problem. Because if that iterator age, it can only get higher and higher. So a way to think about what can be, how you can solve these consequences, can solve these issues. So the first thing, like you said, the Kinesis doesn't handle the scale. So this means that a Kinesis works in a way that you determine for Kinesis is a data stream managed. For those of you who don't know, it gets stream of data, and then it spreads to consumers. So you can configure a Kinesis by, the one way to configure it is to determine how many shards you have. For each shard, it means that you can run the same packet, the same data, it can distribute it concurrently. So if you're going to add less shards than you have in your input, what is going to happen? This iterator age is gonna exceed. So you can just either adjust the shards, you can just think about. So the way the shards work is that when you put something into Kinesis, you basically can tell him to which shard to allocate it. So if I have different types of data, I can what is called a partition key. So if I'm going to give the same partition key, it's going to go to the same shard. So if I have 10 shards and the partition key is the same, it's all going to go to the same shard. This is something that usually people understand only when it's in production and only when you start hitting scale. Anyone here using Kinesis? You? And how did you configure the shards? Or if you're... yeah, no idea. Okay, so only when that Kinesis is going to get a lot of traffic, then you're going to start realizing that you need to take care of this stuff like shards. This is not something that is very serverless way, because if I need to constantly change something in configuration, if my scale is going up or down and it affects my billing, it's not that configuration is just paying like twice on that Kinesis. It's not like something Amazon generously can give you. It just, if you configure another shard, you basically bought a new Kinesis and they are just working together. So adding shards and removing shards is not that trivial. It's not that easy to do. And what I said before about data distribution is even if you have 10 shards, you need to make sure that the data that you are writing is using a random partition key. So it can go, you can use like UID, for example. You can generate something very random, so it can go to each shard. The next thing that can be a problem in this graph is the Lambda, because the Lambda itself can suffer from timeouts. So for example, if the Kinesis how the Kinesis works is that when it sends a message to a Lambda, if that Lambda is not responding, yeah, all good, So he keeps on the side the same data that he sent to the Kinesis, to send to that Lambda, and gonna invoke another Lambda with that. He's gonna try to invoke that Lambda 3 times as a retry mechanism. But if it doesn't work, it's gonna be stayed in the Kinesis itself, and then it's gonna invoke a new Lambda. So that data doesn't go away, and that's why iterator age can go up in that case. So the way to fix it is by just seeing what operation you're doing in your Lambda, maybe trying to improve the performance of that Lambda, and just set up the timeout. So for those of you who tried Lambda, how many said again that there are? Who recently deployed a new Lambda? Okay. So how did you choose the memory and the time limit? Yeah, all right. So usually, and do you know if there's any effect to what you're doing in terms of memory? If you put less memory, if you put more memory, what happens? You're just getting more and less memory, right? So in fact, it's not only that. If you're going to configure your Lambda, when you put memory and you put some different types of memory, it really affects the way your Lambda performs. For those of you who've been in my lecture yesterday, so you're already familiar with that if you're going to take that number that you're going to allocate to the Lambda, it also affects the CPU share you're going to get from AWS. It also affects the network share. So this means that if you are using HTTPS, for example, and you have something that is sending HTTPS requests to some third-party API, if you're going to use 128 megabytes, the damage of the duration is going to be way, way longer. It's going to take like 10 times longer than just sending a regular request, because the network share is now the bottleneck of your Lambda. And this is something you need to keep an eye on. So each time you change this thing, it's going to change proportionally the CPU share and network share. What we did in Hexagon is that we understood this problem. Sadly, we understood it only after we got into production with some of the Lambdas. But once we really understood that, we started to think about how we can help other people and how we can help ourselves first to benchmark our Lambdas. So we built a tool that is basically taking all these different types of configuration and let your Lambda run, and then it's gonna output some graph, some CSV that's gonna show you the exactly performance that happens in each configuration, so you can decide which configuration you want to put to your Lambda. And what we did, we just took we built some Fibonacci function that we gave some large n, and then we ran that on that benchmark Lambda, and then we got some interesting things. So here we can see the memory that we used to configure each time that Lambda ran, and then you can see the effect it has on the duration. And what I think the most interesting part is to see that if I'm gonna put 128 megabytes, and I'm gonna get around 375 millisecond of duration. But if I'm gonna use 256, I'm gonna get twice of the performance. So I'm gonna get 200 duration if I'm gonna use some more memory on the same code. This is all the same code. And basically, you can draw a line here. It's very linear until you're going to get to this part. And what happens is that in this part, AWS allocates you another CPU. So you get 2 CPUs. You get another thread to run your code. Our benchmark didn't utilize that, so it continued to work the same. Usually, if you don't have like a multi-threaded, this means that if you don't have any multi-threaded program that really uses other threads, and you don't need more than this type of memory, there's no change to your duration. And also, in the end, even if you're going to use another thread, that number is going to be significantly lower as long as you go across the megabytes you're going to add. And we also took that beautiful graph, and we tried to see, okay, so how much I'm going to pay. So I think what you can take from all of these numbers and graph is the fact that if you used, if you have your Lambda code that runs now, and you gave it 128 megabytes, you're going to pay around 8.8, and the duration is going to be 376. But if you were to give it 512 megabytes, so now you get much more memory, it's going to run way faster, and you're going to pay the same. So this is something to take in consideration when you use your Lambda. So sometimes you can say, listen, Chen, I don't care. I want to pay more money as long as my clients will get the minimum duration. So you can also do that. This is something that is located in our GitHub. So you can just log in, and you can just use that on your own Lambda and let it run. And then you can gain some more understanding on how to what type of parameters you want to do. So, like I said, use at least 512 for HTTPS, and if you're gonna increase it more than 1.8, you can get another core. Any questions so far? So I'll go back to that example that I did. So out of memory is something that can also happen in our Lambda and cause it to retry. So basically, you just need to adjust the memory side or adjust the kinesis batch size. So maybe your Lambda has been invoked with too much data. So this can also cause bottlenecks. And the next thing is gonna part of all this flow that can cause a bottleneck is our database. So DynamoDB has it's very easy to use. You don't need to build a structure. It's like NoSQL. You can just very easy to set it up and put it in production. They have some limits. I think the AWS already started to overcome those limits, but it's also going to cost you more. So there are two ways for you to configure a DynamoDB. When you configure a database, usually you configure how much limit or read-write limit you can give it, and this is how you're going to get billed by the end of the month by the number of storage that your DynamoDB has and how much read-write capacity you have allocated for it. So if it's going to exceed, if you allocated something very small, when that Lambda is trying to write to DynamoDB, it's going to throw an exception. Those of you who tried Lambda already experienced with forgot the name of it, but it's whatever exceeded exception. And that's very frustrating because it always happens in production. And then what you need to do, you need to call someone and get them to manually configure the DynamoDB. And the thing with DynamoDB, it also offers auto-scaling, but it doesn't really work because you need to set like a minimum threshold. You can tell DynamoDB, okay, if it's going to exceed more than 20%, even 20%, which is very low. If I'm going to start getting more traffic and it's going to be increasing more than 20%, then allocate me more read and write capacities. The thing with that, it just works randomly. Sometimes it works, sometimes it doesn't recognize that you are past the 20%. If you put it even to 1%, then all it can do is like allocate bunch of stuff, and then you're going to continue pay for that. And then the downscale is also takes a lot of time. So this basically means that you're going to pay a lot of money if you're going to use auto-scaling. You just need to find the exact, understand how your Lambda writes that DynamoDB, what is the traffic on the DynamoDB, and then give it like some number that might work for you. There is also a way to configure DynamoDB to be on request. So you don't allocate like read and write limits. You can allocate, you can determine it to be on request. So this means that you basically with that DynamoDB, you pay per use. So you pay for each request of read and write by the end of the month. If you haven't used the DynamoDB, you're not going to pay anything. This is just similar to how we use Lambda. They also introduced that to DynamoDB. So this is a way to use it if you have not a lot of requests that you can use by the end of the month. This can save you some money. But if you have many requests that constantly writing to DynamoDB, the best way will be to use the capacity, because then you know how much you're going to pay and not going to pay by the amount of data. So a little bit about more serverless bottlenecks. So we have a concurrency limit in Lambda. that can cause it. Each Lambda can be invoked until I think 1,000 concurrency. So if you have that, if you're gonna reach that threshold, you're also gonna get bottlenecks for every service that's gonna communicate with Lambda. And basically, any unscalable resource is gonna be eventually a bottleneck. Cold starts used to be think as a bottleneck, but it's not really any of a bottleneck because it's just it adds. If your system can't handle that every 40 minutes, it's gonna work 200 milliseconds more, then you have some issues in other part of your system. So I wouldn't call it cold start because it's something that we can't really do anything about it, and it's not a major bottleneck. It's just add some latency in some sort of situation. So I'm gonna talk now about something that we had in Hexagon. So in Hexagon, what we do, we monitor our customers' functions. And when we started off, we just built something very, very quick. We built something like, it took us 2 days to build, less than a week to put it in production. And what we did is that for each customer that we had, we invoked a Lambda that did the list functions on all these functions. And for each functions of that customer, we invoked another Lambda. And that Lambda just took the logs from its CloudWatch and put it on our RDS. And that used to work pretty damn good because it was very easy to implement. And what we did with the RDS is all the data there, we just put it in our dashboard. So clients constantly kept getting every 5 minutes their updated information of functions. So this worked okay until I didn't say that, but also we use Hexagon on our environment to monitor. And what we have as a feature in Hexagon is the ability to estimate how much money your function is going to cost. So this means that by the way your function operates, we estimate how much money it's going to cost you by the end of the month. So my CEO went through that we call it Meta, our Meta Hexagon environment. And when we saw that this service is going to see something fishy. So he sent a text message to my CTO. I asked him, is this for real? And then he just pointed out that it's going to cost us $30,000, and which is, for those of you who use Lambda, this is a crazy number. This means someone did some major bug. You have something very crazy going in your system. So the CTO just called us in the morning and told us about it and told us we need to figure out what's going on. The thing is that what we realized is that there was no bug. This was just the amount of money this service is going to take us. And when we started thinking about it, what happened, we just realized that this was because of, basically because of bottleneck. So what happened in our super duper 2 days took to implement and few days took to put in production, which was fully serverless and was amazing, and we are amazing. What we really realized about that thing is that we have CloudWatch, which is a bottleneck. And CloudWatch worked in the way that if you're going to try to query it too many times, it's not going to tell you, okay, you have exceeded you used us too much. It's just going to, I don't know why it does that, but what happens is that when you try to run a query, you just wait until CloudWatch is ready and there's an open slot for you. So this means that all Lambdas just waited for other Lambdas in our system to stop bumping it. And each 5 minutes came more Lambdas and more Lambdas and more Lambdas. So this was pretty good for a while. But when you have like 500 concurrent Lambdas running for 5 minutes, every 5 minutes, you basically have 5,000 Lambdas and 10,000 Lambdas and 20,000 Lambdas, and then you have them running forever. So there is no good way to fix this problem because the entire architecture is bad. The way that we approach the CloudWatch is not something that we need to approach it. We can't constantly querying a service that is not scalable. And if we do, we need to come up with some better ways. So this led us to stop what we're doing and go into CloudWatch and understand how it works, and go into different types of services in AWS and then understand how they work. And then we came up and understood that we got CloudWatch wrong, and we don't need to query it for data. We can just use other features that they give, like you can subscribe your CloudWatch to any Kinesis. So what we did, we took all our, when a client registers, we automatically register his Lambda's CloudWatch to our Kinesis that sits on our backend. And what happens is that we also use filtering, so we only put like slimmer data on that stream. So this is how our new architecture looks like. We have CloudWatch streaming to Kinesis, writing to Lambda, and then putting that thing to RDS. So this got the entire flow of our service that used to be pooling. We eliminate all the need in pool, and we turn it into an event-driven environment, which can be scalable. Well, there's like this part doesn't really scale that good. You need to manually change it, but then we have another Lambda that is constantly checking what's going on here and performing the auto-scaling. There's solution out there also in our GitHub. But in terms of conclusions of this entire lecture, so bottlenecks are shit. And if you're incurring them, you need to understand that something, you need first to understand what vendor you're using and all. This I think that sound very common, but only if you go into, and that's something I showed yesterday, so only if you go to different types of services like Firehose or S3 or Kinesis or SQS or SNS, only if you look in the lines of the limit of that service, then you realize things that might affect you if you go into high scale. For example, SQS, you can't, it only sends you messages in batches of 10. So if you think you can use SQS to spread tons of data, it's not really going to work, because then you're going to have, you're going to have the latency and you're going to pay a lot, because your Lambda can run faster than the SQS. And this means that each time the SQS runs, it's going to invoke a Lambda that runs faster than him. And then you have some dead time that you are waiting for more information from the SQS. So things are going to start to add up, and eventually going to have bottleneck if you're going to use SQS in that large scale. I know they're working on improving that. So just need to go and understand how things work and set limits. And I think this is where we try as Hexagon to come and solve this issue, because how can you really understand what's going on if your system, if you're not seeing it, if you're not monitoring it, if you have tons of services talking with each other and you want to understand what is the bottleneck, you have to constantly monitor, you have to in code write, okay, I'm getting X packages, and then in that other service writing, okay, I'm ingesting these packages, and then do all the calculation, or I don't know how many, or stream all the logs to Kibana and do some crazy queries on that to understand if you have any issue. In Hexagon, we try to do that more simply. We give the ability to see. This is an example of a request going from end to end. And we, once you send traces to our system, we gather them together and we aggregate them, and then we can show you a clear view of all the different types of services. If you guys are interested, I can show a demo of that right now. If you guys want, I need people to scream in the. Yes. Okay, so I just prepared. Okay, so this is. By the way, you can. Oh, yeah. Okay, so this is demo.hexagon.com. If you guys are interested, you can just go. This is our live environment. It works with our production environment. And what we did here, we just made up some different types of systems. One is a block site system, and it constantly sending us invocation, and that thing really works in the background, but it's just something that we just created just for the demo purposes. We also have a system that is, so this is the example of the block site system. So this, as you can see, we take all the traces aggregated, and then we show what you see bigger is what is being invoked more frequently. So you can see here you have a system of a couple of lambdas talking with DynamoDB, also talking with Auth0, also writing file to S3, and you can see all the connection between them. You can understand at least by the colors, which are the problematic nodes. This picture keeps constantly changing all the time. You can also select different time frames to understand what's going on. This means that if someone introduced a new service in your system and it runs, so you can see a new service here, and this is pretty useful for like new people in the team to just understand what's going on in the architecture. I can tell you that many times we look into our own architecture and we don't understand because we thought we did some different types of implementing a service, and then eventually it was communicating with something else. You can also like track major issues you have in your system, like bottlenecks, just by looking at the duration, average duration each thing takes. So here I can see I have like three. I think the main thing I can see here that all the requests taking less than a millisecond here, 27 milliseconds, and just to Auth0, I can see that it takes, on average, around 366 milliseconds. So this is my sort of bottleneck in my system. And if I want to like take action on this, I can just go and search. We give the ability to search for every trace that is being sent. So you can just go here, search for Auth0. Hopefully it will work, yes. And then you can see all the events that Auth0 sent to the system. And just by trying to look about something with interesting duration, you can just click here. And so you can see here, I just click on the Auth0 one, and I can see that a Lambda tried to do some request to Auth0. Here we have two lambdas that are communicating via SNS. This lambda is being invoked by API gateway. So if this is a blog site, think about someone trying to post a new post. So this is the API gateway of the new post. It's invoked this lambda, and that lambda is trying to authenticate with Auth0 and then sending a message to SNS. Except that there is like a bug in this entire flow, because if something failed here, why else will it continue the flow and send it a message to SNS? But this is a bug that I need to solve. But if I'm talking about in terms of bottlenecks, I can understand, at least just by looking here, that this Auth0 took 363 milliseconds, and I can see exactly what were the values that I invoked in with, and what did he return to me, and also who else did I affected in that type of flow. So I can see that because I ran 363 milliseconds, it took 360 milliseconds more to send the SNS. And just by looking at this, it's not going to solve my problem, but this can raise some questions. We already discussed this yesterday, but this is going to raise some questions how I can fix it. So people said yesterday that you can fix it by moving to Cognito, because Cognito is something that it's the same as Auth0 in terms of being an identity provider, but it's also it's part of AWS, so this means that all round-trip delay is going to be way, way quicker. And you can do things like I suggested to put it on cache, so I don't have to go to Auth0 each time. I can save all the users in my cache, and only then, if I don't find the user, only then I can go to Auth0, and then I can reduce the overall average duration. Because if I'm going to use Auth0, if I'm going to use anything that is going to be slowing down my system, it's also going to affect my users. There is also a way to view it in a timeline manner, and this is like in terms of understanding what's going on in the system. Anyone has any questions? Want me to show something else on Hepsagon, something else that is interesting? Questions?
Yeah. For the set, you use Kinesis instead of SQS, but I didn't understand correctly why.
Instead of Kinesis to put SQS?
Yeah.
Yeah, so, well, both of them can be used for data streaming. And because Kinesis can't do auto-scaling and SQS can, so you might want to use SQS. But then you're going to get into different problems with SQS because eventually it's going to cost you more. So it's all about trade-off. If you want to mess with the manual auto-scaling, no, you want to pay more and get the throughput is going to be even smaller with SQS.
Is there a danger that you would exceed maximum concurrency on Lambda?
Yeah, well, there's always this possibility. You can ask for, you can request to get that limit raised. We asked it because it was 1,000 functions concurrent is not enough for us, so we kept asking for that. And a way to fix that is to have all those functions transfer the data to a different kinesis, and then try to spread the work between different types of services, different types of Lambda functions, but eventually it's not that optimal solution. The best solution would be to remove that concurrency limit.
Maybe it's a question. Do you support something else other than AWS?
So in terms of tracing, if you look at the function screen that we have, we also support OpenWhisk. If anyone is using OpenWhisk. So in terms of framework, we support OpenWhisk and AWS in the way to show like a list of all the functions and to go to each function and see all the metrics and see all the invocations and go to like the CloudWatch logs. This is, by the way, part of our free tier. If you have like a bunch of Lambdas that are invoked, you don't even need to put Hexagon on it. You can just connect to the dashboard, and what it will do, it will just do that streaming of CloudWatch like I exampled before. And we give that for free, just for us to have you as customers, but just for you also to gain very fast access to like the CloudWatch logs or just see the invocation. Things that you're currently doing today with CloudWatch, if you're not using any other monitoring solution, you can just get in then without any tracing, without even having to pay, and get all of that in terms of alerts. So you can also set up alerts on cost. And for your questions, we support Google Cloud Function and Azure Function. We support basically anything that runs anywhere in terms of tracing, but in terms of the ability to view invocations, we currently only support AWS and OpenWhisk. We are working on also progressing to that, but it all depends on what the customers. Our majority uses, I'm not sure who makes up all these polls, but it says that 70% of the people chose Lambda as their serverless platform, and we just move with what our customers ask for us. So we will move that soon, though.
Can you tell more about how you build your system? Do you use cloud formation, Terraform, serverless framework, SAM, Node.js, TypeScript, Python?
Okay, so Hexagon is 99% serverless. That 1% is just the way for us to ingest tons of events, and we need low latency, so we put that on Fargate. But other than that, we have all our code is written in mostly Python, and we use the serverless framework to deploy. We find it very useful.
Cloud formation, Terraform.
Yeah, so we use serverless framework, so that's the one preparing the cloud formation. In terms of resources, we don't use Terraform, but what we have a plugin for Terraform. If you're using Terraform, we support that too. But in terms of like the resources that we use Lambda. We use everything basically. We use Lambda, Kinesis, RDS. We use SNS, SQS. Anything that we can consume from AWS, we have some service that plays with it. So I think we also have support for containers, but it's not serverless, so boo containers. And in terms of notification, so like I said before, how do I know if I have bottlenecks? So what we try to offer here in Hexagon is you can say, set up really quickly that if one of your Lambda or a bunch of Lambdas have their own, I can just go here and create new alert, and I can select the threshold alert. I can say, okay, if the sum of all the duration, not even the average duration, if the average duration is going to be more than my limit, for example, and my limit, let's say, it's 1,000 millisecond in whatever time frame I want. If I want like if the average for across 30 minutes is gonna be that type of number, then I want to get alert to Slack, email, or whatever. And then what's going to happen? You're going to get your alert to Slack saying this limit has been exceeded. And then when you go to Hexagon, it's going to be appeared here in the issues management. There's a list of all your issues and their histogram. And you can just, from here, you can start investigating. So we just tell you, OK, there's a problem, but the part of you fixing is we haven't done that yet. So you need to go and understand really what caused it. So you saw that limit exceeded. So what is going to happen? I'm not sure if I have the limit example here. Well, if I go to some other example, it's just going to take me to the function screen. It's going to filter out all the invocations based on duration. You can just do it yourself, even if you're not having any alert. And then you can just click here from anything that you have and go back and understand the exact request that happened. And then gain, because here you can see stuff like the payload, and you can see all the operations that it did. You can also see it in the timeline. This can gain you more understanding about why you got this alert and what really happened in that request. So I think I wasted my entire demo. Sorry. So any questions? Another one? Cool.
They say Fargate is also a serverless solution. Can you share what's on that?
In terms of Fargate?
Yeah.
What do we show as Hexagon in Fargate, or what we do with Fargate?
Opinion or experience with
So Fargate is great in terms of that you just no need longer to worry about where your code really runs. So you have your container, and you can use it like. If you can use like ECS or things like that, or if you're going to manually put on EC2 each time. So if you want to scale up, you need to come up with a way to understand what happened and continually increasing that instances and do some manual work. If you're going to put it on Fargate, it's pretty great in terms that it's become less thing to manage. It's not serverless fully because you're paying, but you're paying for the entire instance per hour, but it's still something that is, compared to normal solution, is for us is serverless. Okay. So thank you all.